Hello, and welcome back to the channel and episode 7 of System Design Fundamentals. Today we're tackling one of the most challenging and fascinating systems to design, Instagram. We're not just building a simple photo app here. We're designing a platform that needs to handle over 1 billion users and process more than 10 million uploads every single day. Let's break down what we're building. At its core, Instagram needs to handle photo and video posting, generate personalized news feeds for each user, manage a robust like and comment system, handle user-following relationships, and deliver real-time notifications. The scale we're targeting is massive. We need to think globally, with users from every continent accessing the platform simultaneously. This isn't just about making something that works. It's about making something that works at unprecedented scale while maintaining the fast, smooth experience users expect. Let's start with the big picture architecture. Our system begins with client applications, mobile and web, that communicate through a well-designed REST API. These requests first hit our API gateway, which handles routing, authentication, and rate limiting before directing traffic to the appropriate services. Behind the gateway, we have several critical services working together. Our web and app servers handle the core business logic. The media service is responsible for uploading, compressing, and storing all those photos and videos. The feed service is perhaps our most complex component. It builds and delivers personalized timelines to each user. Our notification service handles both push notifications and in-app alerts. All of this is supported by carefully designed databases for user data, posts, comments, and metadata. And critically important for a media-heavy platform like Instagram, we have a content delivery network that ensures fast global media delivery. Each component is designed to scale independently and handle failure gracefully. Storage is absolutely critical for Instagram, and we need to think about two very different types of data. First, we have metadata, information about users, posts, likes, and comments. This structured data lives in SQL databases like PostgreSQL or MySQL because we need ACID properties and complex relationships. But the photos and videos themselves? Those go into object storage like AWS S3 or Google Cloud Storage. Here's a pro tip. We use pre-signed URLs to allow clients to upload directly to storage, bypassing our servers entirely. This reduces our bandwidth costs and improves upload performance. We also run a compression service that creates multiple versions of each image, thumbnails for the feed, web-optimized versions, and high-definition originals. This gives us the flexibility to serve the right quality for each context, balancing speed with visual quality. Let's walk through what happens when a user posts a photo. When they hit that post button, several things happen in parallel to ensure a smooth experience. First, the app uploads the media file directly to our CDN-backed storage using those pre-signed URLs I mentioned. Simultaneously, the metadata, caption, tags, location data goes to our post service through the API. Once the post is created, we trigger several background processes. We start generating feeds for the user's followers, send out notifications, and log everything for analytics and abuse detection. This asynchronous approach means the user sees their post immediately while we handle the heavy lifting behind the scenes. This flow is designed to be fast for the user while ensuring all the complex downstream processing happens reliably in the background. Feed generation is where Instagram gets really interesting from a system design perspective. We actually use two different strategies depending on the user. For most users, we use fan out on write. When someone posts, we immediately push that content to all their followers' pre-built feeds. This means when you open Instagram, Your timeline loads instantly because it's already prepared. This works great for regular users who follow a reasonable number of people. But what about celebrities with millions of followers? We can't afford to update millions of feeds every time they post. For these accounts, we use fan out on read. When you open the app, we quickly pull the latest posts from the celebrities you follow and merge them with your pre-built feed. We cache hot feeds in Redis or Memcached with TTLs of 5 to 15 minutes, depending on how active the user is. This hybrid approach gives us the best of both worlds: speed for regular users and scalability for power users. Let's talk about how we structure our data. We keep our core tables relatively simple, but highly optimized. We have users storing basic profile information, posts linking media to users with timestamps, a followers table managing relationships, and separate tables for likes and comments. The key insight here is strategic denormalization. While we maintain referential integrity for core relationships, we denormalize counts like the number of likes and comments directly on the posts table. Yes, this means we need to update these counts when interactions happen, but it makes feed generation much faster since we don't need to calculate these numbers on every read. We also use secondary indexes strategically on timestamps for chronological feeds, on user IDs for quick lookups, and on content types for filtering. Scaling Instagram requires a multi-layered approach. Our CDN, using providers like Akamai or Cloudflare, ensures media loads quickly for users worldwide. We horizontally shard our databases, typically by user ID, so we can add capacity by adding more database servers. Load balancers like Jinx distribute incoming traffic across multiple application servers. For asynchronous processing, we use queue systems like Kafka or RabbitMQ to handle notifications, feed updates, and media processing jobs. The key principle here is making everything asynchronous where possible. Upload processing, notification delivery, analytics logging, all of these happen in the background so they don't slow down the user experience. System design is all about trade-offs, and Instagram has several critical ones. For feed generation, we choose between fan-out on write for speed versus fan-out on read for write efficiency. For like counts, we trade some accuracy for speed by denormalizing rather than calculating in real time. For uploads, we choose between routing through our servers for simplicity or using pre-signed URLs for scalability. Each choice has implications for cost, latency, and complexity. The key is understanding your specific requirements and user patterns, then optimizing for what matters most. There's no universally correct choice, only choices that are right for your specific scale, budget, and user expectations. At Instagram's scale, security and abuse prevention aren't optional features, they're core requirements. We implement rate limiting at the API gateway level to prevent spam uploads and comments. Our content moderation pipeline combines AI for initial screening with human reviewers for nuanced decisions. We have sophisticated spam filters for comments and likes, often using machine learning to detect patterns that simple rules would miss. Authentication uses industry standards like OAuth 2 and JWT tokens. Privacy controls let users manage who can see their content, and we provide robust blocking and reporting mechanisms. Remember, at this scale, even a small percentage of bad actors represents thousands of problematic users, so these systems need to be both automated and highly effective. As we wrap up our Instagram design, remember that system design is fundamentally about breaking complex problems into manageable chunks. Instagram scales through smart use of CDNs, database sharding, asynchronous processing, and feed architectures tailored to different user types. The most important lesson? There are no perfect systems, only optimized systems. Every architectural decision involves trade-offs between scale, latency, cost, and user experience. Your job as a system designer is to understand these trade-offs and make informed decisions based on your specific requirements. Instagram's success comes from relentlessly optimizing for user experience while building systems that can handle massive scale. That's the balance every great system designer must strike. Thank you for watching this episode. Next up, we're diving into YouTube Live, where we'll explore real-time streaming and video pipelines. Before you go, I'd love to hear from you in the comments. If you found this video helpful, do give it a like, share it with your friends, and of course don't forget to subscribe to the channel to help us grow. I will see you in the next one. Till then, happy learning.